Alright, I plugged in the National Instruments DAQ module NI9211, and this acts as a thermocouple reader. And what the type of thermocouple we're going to be using is type K. Whoop. Okay, so type K thermocouple, you'll see it's got a positive yellow and a negative red. Another really common one is type J, where the white is positive and red's negative. Those are the main two that I've seen used in the industry and in some of the projects that I've worked on. And they each have different types of ranges as far as temperature goes. And so, for example, here with type J, you can go from negative 210 to 1200 degrees C. Type K is a little bit higher. So if you're looking to test something that's extremely hot, type K is a good one to go with. But if you're really looking for something crazy warm, they do have tungsten type thermocouples that go up to 2300 or so. When thermocouples are not grounded, so the way that those work is they give off a current when they're touching each other, and if they're not touching each other and they're ungrounded, then they'll give off a temperature. We'll look at that as extremely high temperature. National Instruments, National Instruments. And LabView 2019. And when it first came up, you should have seen something that said evaluate and extend evaluation. So when I did that, it had 45 days. Now it's got 39 days remaining into next month, which we should be done with everything by that point in time. So we're going to go to evaluate. We're going to create a project. And hopefully my computer can handle this. A blank VI finish. Okay. So you have in front the first panel is called the front panel, where you see the graphical user interface. When you can include different numbers that you want the user to be able to enter, like with a numeric control. You can put that and just call it number. Alright, so that can be something that the user actually controls. And then you also have what's called the block diagram in the back. So one of the first things that I've always usually start with is some kind of loop to keep the program running until I tell it to stop. And you can do this with a for loop that'll run a certain number of times, a case structure where it'll run until you give it a false statement. But one of the easiest things to do, and one of the most common ways of keeping it running, is with a while loop. And so I'm going to right click on this this little dot by the stop symbol. So whenever this sees a true condition, it will stop. Right click and hit Control. And so now the user has a stop button that appears on the front panel. And so I'm going to take that stop button, I'm trying to move it over here, make it bigger. You see it really well. And you can actually change the font of this to something bigger so you can see it a little easier. So if the user pushes this button, the whole system will stop. Alright, so just to give you an inclination of how some of this works, so let's just say we want to add two numbers together and get a result. So how do we do that? Well, in this structure we've got numeric, and then with the numeric we can choose the addition symbol. And if we get close enough to that number, you see that line forms there. We can either have so it automatically puts that line there for us, or I can just draw it. So I'm going to rename this number 1, and then I'm just going to copy it by holding down Control and then C, clicking somewhere on the white space, and hit Control V. Alright, now number 2 has popped up. So we've got two numbers that I'm going to add together, and I need a solution. So I'm going to right click here, one of the easiest ways to do it, and hit create indicators. So this will indicate what is coming out of that solution. So that's what I'm going to put solution. So out of this addition symbol that we put in here, we can get a solution. So now, let me relocate some of these things so we can see it easier. We have number 2, and then we'll have our solution that'll pop up. Okay. Alright, so to get this program running, if I didn't have a while loop, I could hit this button here and it would just keep continuously running. But since I've got my while loop, and I'm going to just choose to stop it when I want to stop it, I'll have that sitting down here. When I hit this button, it'll just continually run. So 0 plus 0 is 0. Now, if you notice when I start changing this number here, is solution 2 plus 0 is now 2. And I can continually change this and this one to hopefully get the solution that I want there. And now just to stop the program, I can either stop it here, but better practice is just use the stop button, and that'll exit the loop. The other thing that I can do if I'm trying to troubleshoot a problem, and I've got a big VI that I've created, is I can highlight the execution, run it, and now you can see how everything is running through the system. So now if I go back in here and change this to 4 and this to 9, you can see it's added those numbers together to get the solution 13 there. And it gives you just kind of a troubleshooting ability. See that little F right there says that the stop button is not pushed in, so it's false. But when I push it in, it becomes true. And you saw that little T that popped up there. It was true, and so it stopped the program. Okay, that's pretty much the basics. For right now, let's focus on just gathering the temperature data. Well, I have got a module hooked up to my computer, the NI9211. I'm going to right click, and I'm going to look for my NI DAQ MX and then DAQ Assistant, and I'm going to put it here. Some things should pop up. So I want to acquire temperature thermocouple, and I have got 4 different ports, 0, 1, 2, and 3 that I use. I'm going to use 0, finish. And right now I'm going to run it to see what it's going to give me. It's giving me an extremely high value, which means I don't have anything plugged into it. And it's also not reading correctly, because type K, when it's not grounded, should give you somewhere in the 2000. There we go. So 2000 range. So the type K value is not reading anything because it's not grounded. So let's say my units are in degrees C. We're going to say, we have a signal input range of, what was the range that we saw here? Type K is negative 270 to 1372. it'll ever read that low, unless I'm working on something really crazy. Alright, we have our device, and then we can also calibrate it. We're not worried about that. So we're going to now run it to see if it's still, yeah. So we ran it once just to see what value it's giving, to see if it's working. Right, so now I'm going to plug in Thermocouple. Let's see, give me the correct temperature. Change it back to 0. It did not like the negative 270, so we're not using a minimum of 0. I wonder how far this can go before it has an error. I never actually tried to get it below. Let's just stick with a negative 100C. I bet you that would work. Yeah, that'll work. Alright, so I've got the thermocouple in my hand, actually trying to make it warmer. I'm going to let it cool. You can see it's dropping in temperature after I let it go. So it's cooling. So it seems to be working okay. So now I'm actually recording a temperature with this probe. There's a lot I can do with that now, with that known temperature. So the way that I read that temperature, I'm going to right click on the front screen and create a numeric indicator. Okay, now this will give me a thermocouple. Okay. This has nothing going on. Alright, so this has nothing to do with this thermocouple output. But what's interesting is now you should see the thermocouple output, and it's taking a reading as fast as the computer can keep up. Now, one thing that can be noticeable is if you have a lot of these and you don't have a way of slowing down the amount of samples you're taking, it can bog down the memory. And so one way to get around that is to actually put in a wait function here. We'll create a constant. We'll tell it to wait 1 second, which is 1 second is 1,000 milliseconds. Milliseconds. So every 1 second, it will take a sample of this thermocouple output. So I have my fingers on this, and it is going up. So if I had this wired backwards, it would actually, if I put my fingers on it, it would actually start to decrease in temperature. It would start to go down instead of up. So that's another way you can know if you wired it backwards. If thermocouple output goes down instead of up. The other issue that you might come across, and I know some people that have done this, is these wires are made out of specific metals. And so if you use like a normal steel wire and then try to connect it to elongate or increase the length of your wire, it will give you a weird reading. It won't be the correct temperature.